Hi students, welcome to E-Pathshala. I am Dr. Devanai, Assistant Professor of Commerce, Avinashlingam University. Now we have to discuss regarding the non-parametric test. The real life situation, there are a number of occasions when the universe distribution is not normal. Hence, to test hypothesis relating to non-normal populations, there is a necessity to develop a different group of tests which are not based on the restrictive assumption. Such tests which are free from distribution are called non-parametric tests. As regard the historical background about non-parametric test, it could be stated that the chi-square test developed by Pearson in 19 was the earliest of non-parametric tests formulated. This was followed by contribution of several statisticians like Pearman with rank calculation test, which became popular after Harold Hotelling, who used the rank correlation coefficient in 1936. It was in 1945 when Wilcox developed a test for two sample cases. The real growth of non-parametric tests stated taking places. In this session, we will discuss the following non-parametric tests: percent, count, chi-square test, McNemer test, coherent Q test, Spearman rank correlation test. Now we have to go to non-parametric test. Non-parametric test, these non-parametric tests can always address situation where the data are normal in nature, like increase or decrease, no change, or ordinal like ranked. The non-parametric tests in that sense are now strengthening the hands of statistician to analyze and explain and type of situation distribution based on distribution free. The important advantages of using this non-parametric test are they are not dependent on the nature of distribution of the population. They are simple to understand and easy to apply. They are less time consuming, and once the result is statistically significant, no further rank is necessary. They are very useful to researcher where the sample size is very small and adequate data from samples cannot be compiled. They are amenable for application for a type of data, qualitative, quantitative, or ranked. They are not based on very restrictive assumption, and in the case of parametric test. In this non-parametric, which one is coming under the chi-square test? Pearson in 1990 developed a statistics procedure for testing the significance of discrepancy between experimental values and theoretical values obtained under some theory of hypothesis. The test is known as chi-square test. It is a test of goodness to fit and is used to find whether the deviation between observation and theory may be attributional to change or any other factor. Chi-square test is applicable to enumeration data and not to data collected on measurement of continuous scale. The data applicable to chi-square. First one, qualitative and categorical variables applicable in the chi-square test. There are a number of qualitative variables in human population, such as color of the skin, eye, hair, etc. The individual possessing these characters are counted and the number of occurrences in the sample is given in the form of frequency. The characteristics are expected to occur in certain frequencies called as expected frequencies. Similarly, there are a number of categorical variables such as blood group, educational level, employment level, etc. These variables are categorized and the number of individuals possessing these characteristics is count and the number of occurrences in the sample is given in the form of frequency against each category. For example, number of persons with the same blood group are counted and given against each category like A, B, AB and O. The second one, qualitative or categorical variables given in contingency table. Sometimes the investigators may be interested in finding out whether two qualitative characteristics tend to occur together in a given population. In such a case, the individuals are counted for the presence or absence of a specific characteristics and are given in the form of a contingency table. The table 1 presented in the form of a table with the variables, one each in row and column. Under each category, the observations are placed in two categories. This table is a 2 into 2 contingency table since data are presented in 2 rows and 2 columns. Depending upon the numbers or categories for each variables, the number of rows and columns vary. The third one is a qualitative or categorical variables in the form of proportions. The demographic may be interested in finding out whether the proportion of material status of men in 4 different cities in the same. He counts the number of persons married and single and present in the form of proportions like married divided total and single divided total against each city. The condition for validity of chi-square test. Chi-square test can be used only if the following conditions are satisfied. N, the total frequency should be reasonably large, say greater than 50. The observation in the sample should be independent. This means no individual item should be included twice or more in the sample. The next one is no theoretical frequency should be small. Preferably, each theoretical frequency should be larger than 10 but should not be less than 5. The data should be given in original unit basis. Next one is application of chi-square test. Which way we are applied the chi-square? Chi-square test of goodness of fit or chi-square test with the superior hypothesis. Goodness of fit is a generic term used to indicate how fair an observed frequency distribution fits well with the expected frequency distributed based on some theory or expectation. Since the expected frequencies are calculated based on some theory or hypothesis, it is also called chi-square test with the superior hypothesis. Next one is, in this case, the null hypothesis is there is no difference between observed frequency and expected frequency. We are framing the alternative hypothesis is there is a difference between observed frequency and expected frequency. The second one, chi-square test for association between attributes or independence of attributes, or chi-square test without a superior hypothesis. It is used to find whether two characteristics have the tendency to remain together or remain independently. For example, whether a person suffering from a disease is cured because of the drug or the recovery from illness is independent of the drug. In this case, the frequencies are given with the form of a contingency table. Hence, the null hypothesis is there is no association between two characters. That is, the drug ID not affect incurring the disease. The alternative hypothesis is there is an association between two characteristics, that is, the drug is effective incurring the diseases. The third one, chi-square test to test the equality of proportions. In addition to the above, chi-square test enables one to find out the significance of difference between two or more population proportions. As stated, if an investigator is interested in finding out whether the proportion of married men in the same 4 major cities, the null hypothesis, the proportion of married men is the same in 4 major cities. The alternative hypothesis is the proportion of married men is not the same in 4 major cities. The next one, chi-square test of homogeneity. Sometimes a need to compare samples taken from 2 populations differing in some characteristics. For example, samples are drawn from 2 populations, namely normal and liver diseases patients. These 2 samples are then classified in 2. First one is persons with hepatitis and person without hepatitis. Here, chi-square is used to find out whether 2 populations from where the samples taken are homogeneous or not. In this case, the null hypothesis, the 2 populations from here, the samples are drawn or homogeneous. The alternate hypothesis is the 2 populations from where the samples are drawn or not homogeneous. The alternative hypothesis is 2 populations from here, the same samples are drawn or not homogeneous. Through 4 different applications are given for chi-square test. All these tests are basically same, as these tests find whether the observed frequency fits well with expected frequency, that is null hypothesis, which is expressed hypothesis equal to O subscription I minus E subscription I equal to 0. But the statement of null hypothesis differ. The next one, procedure to carry out chi-square test. The proposed null and alternative hypothesis to calculate expected frequency, find the deviation between expected and observed frequencies. The next one is square the deviation and divide by respective dependent frequency. The next one is substitute in the formula, write the degree of freedom, refer the tabulated chi-square test value for the specified degree of freedom at 0.01 probability level, compare calculated chi-square value with tabulated chi-square value. The above procedure is routinely done to work out any problems manually or with calculator. But when we use SPSS, there is no need to do any of the step from 2 to 8. We need to propose the hypothesis, enter the data correctly, run the analysis and interpret the result. Throughout this chi-square test, the minimum expected count is expressed in the 7.50, which is expected the expected count less than 5%. Output on this table gives the frequency of blood groups in male and female in the table form for 3 degree of freedom, that is R minus 1, column minus 1, that is a row minus 1, column minus 1, equal to 2 minus 1, 4 minus 1, we had a 3. The p value is 0.852, is greater than 0.05. The difference is considered insignificant. The null hypothesis is accepted and therefore there is no association between sex and blood group. In other words, the gender and blood groups are independent in human. Non-parametric significant test, which is used to calculate 2 dependent samples. The researcher would like to study correlated or matched samples. It includes the calculation of before-after effect of matched pair studies. The next one is Vidya-mitra test. Vidya-mitra test was first time published by a Psychometrica article in the year 1947. Vidya-mitra test was created by Vidya-mitra, who was a professor worked in a psychological and statistics department at Stanford University. The non-parametric test assesses which a statistically significant change in proportion have occurred. The McNamara test is the best test for trigonometric variables with two dependent sample studies. When a category of the sample is more than two marginal homogeneity tests, or appropriately they are essential on extension of the McNamara test for dependent samples. When the dependent variable samples are continuous in nature, then the Sine and Wilcoxon test are appropriate for two dependent sample studies. In medical research, if a researcher wants to determine whether or not a particular drug has an efficient on a disease, example, which one is given yes or no answer, then a count of the individuals is recorded as plus or minus symbols or 0 and 1 in a table before and after being given the drug. The McNamara test is applied, which is help to take statistical decision, which is whether which one is acceptable or not a drug has an effect on the diseases. The McNamara test work out the following way. We have to assume that the row total is equal to the column total. In other words, A plus B equal to A plus C, C plus D equal to B plus D. In this workout is cancel A and D equation, and this implies that B equal to C. Through on this calculation, explain the equation, we will calculate the test as psi square equal to B minus C whole square divided B plus C. The following question arises in this particular test. Is there is a change in the proportion of voters prior to and following the press conference? Does the proportion of success versus failure significantly change after treatment? The hypothesis framing. Null hypothesis. Assume that the total rows are equal to the sum of columns. The mean of paired samples are equal and no significant changes has occurred. For example, the null hypothesis assumes that the drug has no impact on diseases. The alternative hypothesis is assume that the total number of rows is not equal to the total number of columns, or that the paired sample means are not equal. In medical research, for example, alternative hypothesis assume that the drug has an impact on the diseases. Next test is a Cochrane's Q test. It includes two various statistical tests. Cochrane's Q test, a non-parametric test, which is applied to the Cochrane test to analyze of two-way randomized block designs with the help of binary respondent variables. Cochrane's Q test is an extension to McNamara test for related samples that provide a method for testing for differences between three or more matched set of frequency or proportions. Cochrane Q test whether the probability of a target response is equal across all conditions. Verify if K treatment have identical effect. Example, 12 subjects are asked to perform 3 tasks. The outcome of each task is a trigonometric values, that is success or failure. This test, Cochrane's Q test, is based on the following assumption. First one, a large sample approximation, in particular, it assumes that B is large. The blocks, that is row, were randomly selected from the population of all possible blocks. The next one is the outcomes of the treatments can be coded as binary responses, that is 0 or 1, in a way that is common to all treatments within each blocks. For example, the researcher who had collected the pet shop data wanted to examine whether pet stores displayed different reptiles during different times of the year. So the researcher visited each of the 12 stores 4 times during the next year that are chosen because of their proximity to holiday, Volunteers Day, July 4, June, Christmas Day, which is taken for this account. During each visit, the researcher recorded if the shop displayed only snakes or both types of rabbits, which is coded 0 and 1. In this analysis, the one variable is the time of the year and the response variable is the time of the rabbits displayed. The research hypothesis. The researcher hypothesized the pet shops would be more likely to display both reptiles to Christmas than during other times of the year. Hypothesis stores are equally likely to display both types of reptiles during all parts of the year. The next study is a Spearman's rank correlations. This is one of the most popular non-parametric tests. In this test, the difference between the ranks of one sample and the other is computed and based on the difference, which is squared. The correlation is computed. Then the standard error of the rank correlation coefficient is calculated with the help of this formula. Rank correlation is expressed the formula equal to 1 minus 6 sigma d squared divided n into n squared minus 1. This process is followed when the number of items in a sample is less than 30. When the sample size is greater than 30, then the following process will have to be followed to test the result of rank correlation. The example, a health organization studies problems relating to the relationship between air quality and the evidence of pulmonary related diseases. The details are given below that test the hypothesis that there is no correlation between air quality and pulmonary related diseases, which is expressed in the table. Now, the rank correlation is found using this formula 1 minus 6 sigma d squared divided n into n squared minus 1. Throughout this calculation, the rank correlation answer 0.736 suggests a substantial positive association between average air quality and the occurrence of pulmonary diseases in the selected event cities. To test the hypothesis set for this problem using the table value for the sample size minus 11, it could be noted that the critical value for R lies between plus 0.6091 and minus 0.6091. Since the calculated value of rank calculation lies outside the limit, we reject the null hypothesis. Hence, there is a relationship between air quality and occurrence of pulmonary diseases. In this study conclude, we are discussed about the chi-square test, percent, Cochrane test, Vidya-mitra test, some other tests we are discussed in this non-parametric. I want to conclude this session. Non-parametric significance test, which is used to calculate two dependent samples. In this samples is more useful in this particular study. In the other Cochrane skew test, the outcome of the treatments can be coded as binary responses. Which one is useful for the medical field? More effective, and this is it express the common to all treatment within the each blocks. Then next one is since the calculated value of rank correlation lies outside the limit, we reject the null hypothesis. Hence, there is a relationship between air quality and occurrence of pulmonary disease. In this medical field, those kind of tests is more useful to testing the diseases. So, diseases and the valuation of effect. So, the application of non-parametric test is more useful in to find out the solution to the problems. Thank you, students.